recording. Okay, this is what she assigned for homework, and some of you haven't had a chance to look at it. Oh, where's the page? Missing a page. Here are the answers. Comments, questions, concerns. If you got something different than I got, let me know and we'll go through it. And I want you to show me your work. If you do not show me your work, you will not receive credit when you do this on a test or a quiz. This is down to number 12. Questions, comments, concerns. Going once. Yes. Number 6. Let's do it. Here we go. So I've got 15 plus 11 minus, and then in brackets, 7 minus 1 plus 17. So BEDMAS says we do what first? B stands for? Yes, parentheses. Brackets. 7 minus, and then inside those brackets, it's all addition and subtraction. So we go left to right. 7 minus 1 is?
6.
So if I'm going to really break this down, the 15 plus 11 minus bracket, and we're going to show all the work. 7 minus 1 is 6. That's the one thing I'm going to change. And I'm going to continue to operate inside those brackets. 6 plus 17 is?
23.
23. So I'm going to still have the 15 plus 11 minus. And now because all the work is done in the brackets, I don't have to continue to write the brackets. Sahib, you're late. Do not be late. Hold on. Wait. I got him do Sahib. But where is Sahib? Sahib, are you still in this class? There you are. You are here, but you are late. And now we've got 15 plus 11 minus 23, which means we just go left to right. 15 plus 11, you can do longhand if you want, or 5 plus 1 is 6, and 2 tens is 20. Minus 23 equals 3. So if you got something different there, do you see where your journey went astray? Benita, you follow what you see what you did and where that went? Okay. Okay, so that's down to 12. Any other comments, questions, concerns? 1 to 12. Going once, twice, thrice. Sold. Boom. Here's the bottom 4. 9, 6, 104, and 72. Comments, questions, concerns on any of those 4? Going once, twice, thrice. Sold. Okay. 17 through something. What is that number? 26. Comments, questions, concerns. 17 through 26. Yes. I would love nothing more. Let's do it. So, actually, I'm going to erase what's already there, because that, 23. Okay, BEDMAS says, brackets. There are brackets, but is there anything going on inside the brackets? No. So the brackets are done. There are no exponents. Division and multiplication. Are we multiplying and dividing anything? When there is nothing written between a number and a bracket, what is the operation? Multiplication. So we are multiplying. We're multiplying here, and we're multiplying here. So we can do both of those actually in the same step. Negative 1 times negative 1 is? Positive 1. For reasons Pac-Man showed us 2 days ago. 2 negatives multiplied to give you a positive. And then we're going to add to that. What is 1 times negative 1? Negative 1 or minus 1, absolutely. And now we want to add those two things together. 1 plus negative 1, that's the same thing as 1 minus 1 is? 0. Yes, Mila.
24, pretty please.
I would love nothing more. 14 minus 7, brackets 0 in the numerator, over 7. Okay, BEDMAS says, what do we do first?
Multiplication.
Do we do multiplication first? Are there brackets?
So we would do 14 minus 7 first?
Let's see. This is the thing. Okay, so there are two sets of brackets here, believe it or not. There's the invisible implied brackets that have not been written down that you absolutely need to make sure you get into the habit of writing down. And there's the obvious brackets that don't do anything. Right now, there's brackets around 0. There's no math inside there. What you need to make sure that you remember, though, is that there is the implied numerator brackets. So if there's no brackets, but there's a bunch of math inside the numerator, you need to make sure you treat those like brackets. Ultimately, that doesn't change anything, though. We're still going to do the stuff here. Inside the brackets in the numerator, we've got subtraction there, and what's going on between the 7 and the 0? Multiplication, so that needs to happen first. 7 times 0 is 0. And that's how we got this. So this is going to become 14 minus 0 over 7. 14 minus 0 is? 14 over 7, which is a nice clean division, gives you 2. It's my classic trap of brackets after subtraction or addition. You are not the first. You will not be the last person I caught. Yes, Benita. Where'd I get you? Slower? Okay, slower and different. Okay. Where did you get snaggled? The very first step, okay? So you're cool with the implied brackets in the numerator, so that's what we're focusing on up there, okay? The important thing to remember when you've got brackets anywhere is you need to make sure you check to see if any of those brackets are implying multiplication. And what I mean by that is, do you have a number and a bracket butt up right next to each other, and that number isn't contained within the brackets? So like right here. Because there's a number, the 7 is here, the bracket is there. The implication here is that multiplication is happening there. And so even though it's not explicitly written, there's no X, there's no dot, this is the step that has to happen first. So 7 minus 0 is 0. And then the 14 minus this result is going to be what happens next. Does that help? Okay. And that is a wonderful classic mistake that every year, grade 9, grade 10, I had physics 11 who make that mistake. It's really important that you slow yourself down and ask yourself, what's being implied by what's here? Well, there is multiplication there, so that multiplication has to happen first. The bottom chunk looks like this. Are there any of those anyone wants done or explained? Going once, twice, yes. 30. Let's do 30.
I somehow got negative 5 instead of 2.
Okay, you know how you got negative 5?
I went negative 10 over negative 5 and then it equals negative 5. I think.
Well, that is negative 10. We're doing the numerator first. There's brackets there. It's obviously there. And there is only subtraction going on in there. So negative 9 minus 1 means you're going more negative.
So I went negative 10.
It's going to be negative 10 over negative 5. I don't know how you would have gotten negative 5 because there's no way to conceivably get negative 5. Yes, there is. Okay, but let's talk this through. There's 2 negatives there. 2 negatives means your answer has to be positive. So whatever next mistake you make, the value has to be positive. So then if you look at 10 over 5, it's conceivable that you said, 10 minus 5 is 5. But your answer was negative 5. So you would have said negative 10 plus 5 is the only way you could have gotten 5. So you need to watch the double negatives.
I simplified it wrong.
Oh.
Yeah, my brain wasn't braining yesterday.
Oh,
so
you
I
reduced the
did that.
fraction horrendously.
Yeah,
Nice.
I did that.
Yes, love that. So then it's going to be positive whatever it is.
Yeah.
10 divided by 5, because that's what a fraction means. And it does divide nicely. is 2. You divided 10 by 5 and got 5.
Yeah.
Classic. But then somehow made it negative still. Yes. Sure. Oh, there's nothing to do with 26. The only thing to look at is the fact that you've got a fraction with 0 in the denominator. It doesn't matter what the numerator is. Are you allowed to divide by 0? No. Without doing any work, this question is immediately undefined. As soon as you see a 0 here, like read the whole question, as soon as 0 shows up in the denominator, there's nothing else to do. Regardless of what's in the numerator, the whole question is undefined. So there is no work to show. By definition of divisibility by 0. Okay. Here is 31 to 38. Questions, comments, concerns on any of those? Is there anything anyone wants to see me do? Discuss it all? 29, 21, 1, 3, 5, negative 13, 0, and 2 are the values that you're looking for. Mark, wake up. Mark, thank you. Yes, good toss. 39. I haven't even got to 39 yet. You don't even know if you're right or wrong for 39 yet. Unless you didn't do it. You did do it? I haven't shown you what the answer is yet, though. 31 to 38. Is there anything there anyone wants to see me do? Going once, twice, thrice. For Guntoss, the answers to 39 and 40 are both 1. Would anyone like, do you still want to see me do it, Guntoss? Okay, so there we go. So you got to wait to see the answers.
I didn't get 35, right?
Okay, well then let's discuss.
-3 from.
That's a phenomenal question that no one conceivably can know. Okay, so let's be really careful and deliberate about how we do this. We got to show our work. Okay, BEDMAS says a bunch of things, but BEDMAS says brackets have to happen first. Are there brackets with math inside them? Yeah, these ones alone. So, what is -1 times -1? Positive 1. And now write down everything else you haven't touched. Negative bracket, -1, bracket times 1, bracket -1, bracket plus 1, minus bracket. That's what we've done. Divided by -1.
Wait, wouldn't negative and then bracket -1 be a positive 1?
I haven't done it yet. I don't know.
I don't know.
We did brackets first. I made one change. I wrote down everything else we haven't done. The other classic mistake of math students is rushing and then not writing down all of the things. That's where you drop minus signs and jazz. Make sure you work it right below. Ms. Cruson did a phenomenal job yesterday of demonstrating this. And I will continue to tell you this. Your work should happen right below the question. So now, BEDMAS, the brackets are done. There's no exponents. Division and multiplication. Yeah, there's a bunch of it. We're going to go left to right. Here, what's -1? There's nothing in here, so it's multiplication. -1 times -1 is? Positive 1. Let's change a few things as we go. There's still times. Let's do this bracket here, there.
So that'd be -1.
That would be -1. Plus, there's a 1 there. There's a minus. And then what is 1 divided by -1?
1 divided by -1.
Positive divided by a negative is? A positive 1 divided by a negative is?
A negative?
A -1. There's still multiplication there we haven't done yet. 1 times -1 is? -1 plus 1 minus -1. So now we're going to get -1 plus 1. This double negative here is going to make this positive 1. And now we can just keep going left to right. Oops. -1 plus 1 is 0. Plus 1 is 1. It's confusing when all there is, I mean, it can look confusing, absolutely, when all the numbers are 1. It's just hard to look at, but that's how you do it.
Thank you.
No worries. And then question 40 is also 1.
Yeah, I got that one.
Okay. There are no other comments, questions, concerns. We're happy with how things went. Great. If you got anything wrong and you don't want to know why because you don't want to ask the questions, pull me aside later and I can answer any questions you may have. If you didn't get it done, shame. Shame. None of you should get that reference because you're all too young. And the show is crap. So here we go. Find me this page over here. We are going to review fractions. And for some of you, yes. For all of you, I hope this is a trivial exercise. Yes, but I hope it's not difficult, is what I'm saying. Trivial means I hope this is easy, but we got to review it because sometimes, you know, you golfing in the summer and you get struck by lightning and now you have amnesia and you forgot everything. So let's review what you have forgotten. Here we go. So, and we have to do some definitions because there's middle school teachers everywhere that just teach shortcuts. I hate shortcuts. So let's understand what's going on here. Fractions represent how many equal portions you have of a whole, whatever that whole happens to be. How many slices are there at the beginning? How many slices are there in this whole pizza, not is this whole pizza. Yes, it is whole pizza. How many slices are there to start? 6. How many are still there? 6. So we could conceive of this as being one whole pizza, but if you're mathematically neurotic, like I happen to be, you could also think of this as being 6/6 of a pizza. And if you want to be really annoying at parties, refer to the pizza in terms of fractions, and people will be annoyed. So you have 6/6 of the pizza, or we can look at this and say, well, that's one whole pizza, which is obvious, I hope, because fractions are just another way to demonstrate division, and anything divided by itself is 1. So we've got the relationship there between the 6/6 and a whole pizza. Take a look at the next one. Assuming they were all cut evenly, how many slices were there to start? 6. It's the same pizza, right? So we lost 1 slice. There are 5 remaining of the whole thing. And so what this is going to give us is how much should have been there. There was 6 in the whole. So we could talk about there being how many slices were taken, 1, or we could refer to the slice that is missing as a fraction of the entire pizza. We would say you took 1/6 of the pizza, if you want to be difficult at parties. And how much is remaining? Well, 5/6 of the pizza is what's left. Beautiful. When we draw the pizzas, fractions become easy. If there are 2 people sharing the pizza equally, how many equal slices does each person get? Well, if we started with 6 equal slices in the entire pizza, divided by 2 people, that's just 6/2, which is just a fraction.
Which equals 3.
It equals 3. Yeah. How many slices would each person take if there were 6 people? 1. They would get 1/6 of the pizza, or the total number divided by how many there are. There's all sorts of ways to think about these things. All of them involve fractions. Obviously, fractions have 2 parts. You're familiar with this before. Let's talk about it again. For those of you whose English is not your first language, I'd be interested to hear what you call them in Spanish or Portuguese or German or whatever language your first language is. The top part of the fraction is called what? The numerator. Is that the same in Spanish? Okay, so yeah, effectively, you just say it fancier. But it's the same word. We've got the numerator. And the bottom is called the? Denominator. The denominator refers to the parts that are how many wholes, and the numerator is what was taken from the whole. Again, just so we're really clear, we got to clarify the language. There's three kinds of fractions: proper, improper, and mixed. What is the difference between these three? What makes a fraction a proper fraction, Mishwa?
The top half is bigger than the bottom half.
Sorry, which one did I ask for? You're giving me improper. Okay, cool. Improper fractions have a numerator larger than the denominator. Give me an example, Mishwa. 2 over... Give me something that does not have a denominator of 1.
8 over 4. No, 8 over 4.
That doesn't divide evenly.
16 over 4.
That doesn't... Give me an odd number denominator and an even numbered numerator. 6 by 5. I love 6 by 5. There is nothing to simplify there. Phenomenal example of an improper fraction. 6/5. It is improper. The numerator is larger than the denominator. Proper fraction then would be the opposite. What's the opposite of that?
The numerator being smaller than
The numerator
being
is smaller than the denominator. Gotta make sure we spell that properly. So, Pevney, give me an example of a proper fraction.
Do you want it to be able to be simplified?
I want it to be in lowest terms.
Do you want to?
Half. 1 over 2. Nice, simple, proper fraction. What is a mixed fraction? Sometimes they're not called mixed fractions. They're also called mixed what, Guntas?
You will think of it itself.
I'll come back to my question and continue with yours. What is a mixed fraction?
A number that still has a...
Okay. So it is a whole number. I don't want to write the word number, so I'm putting that symbol. That symbol means number, not hashtag. A whole number and a proper fraction. So Guntas, give me an example of this. 9 4/7. I don't know why, but that is perhaps the ugliest example you could have given me. I love it. I hate everything about what you just asked me to write down. 9 4/7. I don't know why, but I don't like it at all. But it's perfect. It's exactly what I wanted. A whole number and a proper fraction, and it's not simplifiable. I love it. It's awful. What is another way to call it? Because calling it a mixed fraction is a little disingenuous because it's not just a fraction.
Mixed number?
Well, a mixed number.
Mixed whole?
The mixed number, I think, is a better way to call it because you've got your integer and you have your fraction. But they're also called mixed fractions, so let's be clear about what that is. And those are examples of all those things. And so we're going to review how do you move around back and forth between them. Here we go. Flip the page. Simplifying fractions. Another way to talk about simplifying fractions is to talk about reducing them. Another way to talk about reducing them is to do what? I've said it already. You want your fractions in
Terms.
lowest terms. All of that language means the same. If I ask you to simplify, reduce, or write in lowest terms, all of those instructions mean exactly the same thing. So, this whole pizza is 6/6, or 1 whole pizza. This is 3/6, also called
1, 2.
a half. 1 over 2. How do you get from that to that? Other than looking at it and being like, oh yes, this is obviously, you took 3 pieces, there were 6, now you have a half of a pizza. And the English language does a good job for us. Oh, hands are popping up all over the place. You haven't heard yet, Mila? So what do you?
Divide by 2.
What do you mean?
Both the numerator and human.
Okay, so method number 1 is the one that Mila just gave us. You want to divide the top and bottom numbers by prime numbers if you can. To review, a prime number is a number that's not divisible by anything else. A prime number is only divisible by 1 and itself. So you picked the easiest prime. You said, oh, 3 and 6. Actually, no. Oh, no, Mila.
No.
Check again. You were wrong. We're not dividing by 2. What prime number are we dividing by?
3.
3. You want to divide the top and bottom number with primes until you can't go any further. So the prime number you can divide 3 and 6 by is 3. We divide by 3. We divide by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. That's a nice easy one. Let's go 6/54ths. What's the smallest prime number that we could obviously divide by, Mishwa? That is the answer, but that wasn't the question that I asked. The question that I asked was, what is the smallest prime number we could divide 6 and 54 by? There's a smaller one. 2. Why? How do you know? Because both of those numbers are even. If you can't, so Mishra, you just went straight to the end. That's method number 2. Method number 1, if you're like, I don't want to think about this, I just want to start dividing it down. You pick small primes using the division tricks we know. These are both even numbers. 4 and 6 are both even. If a number ends in a 4 or a 6 or a 2 or an 8 or a 0, it's divisible by 2 automatically. So let's go. We divide by 2 both of those numbers. 6 divided by 2 is 3. 54 divided by 2 is? If you don't know, you can long divide it. You got the multiplication table. 54 divided by 2? Someone said it already. Who said it? It's 27. If we... Because you're not allowed a calculator. 54 is not divisible, not divided by 2 on here, so we're not going to use it. You just got to... That's one you got to know. That's not on the 20 by 20 table that I gave you. And we can keep going. What's another small prime number we could divide by? Your hand was first, Pevney.
3.
3. 3 over 3 is? 3 divided by 3 is? 27 divided by 3 is? 9. And what Mishwa said right at the beginning was? 1/9, and she was right, assuming we all made a mistake. That is, okay, so then I think this is what Mishra wanted to do before. Method number 2. What you could do instead is if you want to spend the extra second and think about it, what you could do is you could find the greatest common factor or even a common factor that divides both the top and bottom number. The GCF is the biggest number that can divide 2 numbers to give a whole numbered answer. This you can use your multiplication table for if you'd like. So, if we're going to do that, I'm not going to write this, I wouldn't make you write this out every time, but I'm going to write down how I would think about it. What are all of the factors of 6? What are all the things you can divide 6 by? Guntas. You cannot divide 6 by 12. 12 is bigger than 6. And 1. Those are the factors of 6. What are the factors of 54?
18.
Yes, 18 and okay. So here's a really easy way to do the factors. Do them all in pairs. 18 is where you want to start. Okay, let's start with 18. What times 18 is 54? 3. Not where I would have started. I would have started with 1 and 54. I would have then said, okay, well, give me another pair.
6 and 9.
6 and 9. And now we've met in the middle. And this is where you're also going to see 2 and 27. So this is the list of factors of 54. 1, 2, 3, 6, 9, 18, 27, 54. What's the biggest number shows up in both lists? 6. So that's the thing we're going to divide by. Again, I wouldn't necessarily write this down every time, but that's how I would think about it. And that's how, Mishwell, you did it. So we're going to divide by 6. We're going to divide by 6. This requires the math facts, or at the very least, the table. 6 over 6 is 1. 54 over 6 is, or 54 divided by 6 is 9. And you want to make sure you're in lowest terms. Obviously, when the numerator is 1, you're in lowest terms. If the numerator is ever not 1, you need to make sure you can't go any further. Okay. Flip the page. You have 10 minutes. Crank out this page. On your mark, go, if you haven't already. There are 9, 10, 11, 12 questions there. You have 10 minutes to do 12 simplify the fraction questions. If you're done, just be love and enjoy life. Some of you haven't gotten them done. You should be able to crank it out. That's great. Just be crank them out. You bet. Yeah, you do. Yesterday, you were yesterday. It is. I'd also like you to reduce the fraction. So for question number 1, A, B, and C, first give me the fraction as the question is stated. So like for question 1, there's 12 cookies, he ate 4. What fraction did he eat? He ate 4/12 of them. But I also want you to reduce that. 4/12 is also how much? 1/3. Give me the fraction as the question states it and reduce it. And for those bottom ones, I want you to reduce. Sure. Now what is 9 divisible by? That's divisible by 3. What's 15 divisible by? 3. Oh, sorry. If you want to, there you go. If you need to go and I whatever is happening, just get up, write your name and go. Yeah, sure. Which one? Mine's 24 pencils and 18 pencils are number 1. Fraction. So how many are number 3? And how many are there total? I wouldn't write it that. You want to be careful. You want to be really deliberate about how you're writing. It's technically what you're doing. So you're saying you have 4/12. What you mean is I'm going to divide this by 4. I'm going to divide this by 4. So that's going to give me 1, and that's going to give me 3. What you wrote down actually means this. If you have 4/12 divided by 4, that's actually 4/12 divided by 4/1. And when you divide a fraction by a whole number, you multiply them by the reciprocal. So it's going to be 4/12 is the same thing as, so you're going to get 1/12. What you wrote down and what you meant is not the same. You want to be sure you're consistent. You didn't answer money. You baked 12 cookies and ate 4. But how many fractions? What fraction of cookies did you eat? Not how many what fraction of cookies are left over. You answered the question, how many cookies, what fraction is left? The question asked you, how many? You answered the other question. A reasonable one to answer, but not one was asking you. Oh, no, that's not effective. Okay. So fractions are always, the way you write fractions every time. Fractions are always how many over what's left. So for the first one, how many did you start with? 12. So that's what's going to go in the bottom. And the question says, how many did he eat? Yeah. So the question one just wanted you to think, what's the write that situation as a fraction. That's all question one was asking you to do. So then the second part that I added is, okay, now that you've done that, reduce. So are 4 and 12 divisible by 8? No, just I'll tell you what to do here. I will tell you what to do. Don't worry about it. Right now, I just want you to worry about this. So 12. So 12 shows up there, 12 shows up there, 12 shows up there, there. That's the only place that 12 shows up. That's what I like. There, and the only place that 12 shows up. So what that means is 12 is going to be divisible by 1, 12 is going to be divisible by 6, 2, 12 is going to be divisible by 4. When you're simplifying, you just want to start lowering. So if you started here and said, oh, 12 is divisible by 2, okay, well, let's divide by 2. Is 4 divisible by 2? Yeah, 4 is divisible by 2. So let's divide them both by 2. Okay, so we said, okay, divide by 2, divide by 2. 4 divided by 2 is 2. 12 divided by 4 is 6. Can I go further? Yeah, 2 and 6 are also divisible by 2.
It's like
2 divided by 2 is 1. 6 divided by 2 is
We have 12 minutes.
so E8 1 E8 1 E8
It's only
4
one page.
12
So,
or a third of the cookies.
yeah.
These two, I want you to write down that is your answer, that is your answer. Show me the wrong. You didn't have to divide by 2. You could have gone straight, okay, you did 4 over 12. You could have noticed, you could have said, okay, well, 12 is divisible by 4. It's one of the things that we looked at, but I also have 4. 4 has to be divisible by 4. 12 is also divisible by 4. 4 on 4 is 1. 12 divided by 4 is 3. You could have gone straight at the end. So there's multiple ways to reduce. That makes sense. Okay, try next. Again, stay with me for you. You are ready, so. Nice. I mean, you can do it every day if you want.
Yeah. Take your time.
We're talking to them.
No, they were talking about.
Okay, gentlemen. Okay, you're done. He's hard to start. Yeah, you finished. Finish. No. You've done nothing. You do not need to leave ever. I'm gonna throw up on the screen in a second. If you have specific questions, I will answer them, but I would. No, snap, stop. Focus on what you're doing. You're in math. He's done again. He's done. You're not. Both of you were done. That's a different story. Hello.
tell her. And I feel like I should tell her that. I feel like I should tell her that.
I will tell you when we get there.
So I'll just say it.
If you want to keep going, keep going. If you want to do work ahead, then work ahead. But I'm not going to tell you what I'm signing.
I would like it too, but I think it's pretty unsolved. Right, that's what I was saying. Like, I'm just like,
Okay. What do you want? Are you trying to come up with your one?
What did you get for F?
Start simple. 14 and 15.
I thought that was
Fine.
recruiting.
I don't even remember what I said.
They are even. Even on the fine. Start there.
What did you get for engineering? That's probably the right answer. I was like, there's no way.
You're not done. I'm enumerating.
Okay. I need. Not
By 27 by anything? I'm trying to be elegant, takes you away from the solution. Right, fix it. All right. I is not correct.
What'd you get for H?
Okay. Let's talk it through.
Oh, wait, you're so right.
Lots of you are almost done. Okay. Let's crank it out, shall we? Gurman baked 12 cookies. He ate 4. What fraction did he eat? It's important to make sure you read the question carefully. Not how many are left. Mishra. He ate 4/12 of the cookies. How many he consumed divided by how many there were. And that is reducible because 4 and 12 are both divisible by. We could divide them by 2, or we could go straight and divide them by 4. 1/3. He ate 4/12 or 1/3 of the entire plate. Maya has 24 cookies, 24 pencils in a box. 18 pencils have number 2, 6 pencils are marked number 3. What fraction are number 3? Pavneet.
1/4 of the pencils, or number 3 pencils, and.
Give me the first fraction. What fraction did you reduce to get there?
I don't remember the first fraction.
Write down all your work. Mila.
6/24.
6/24. If you don't recognize, okay, so here's how I would use, just so we're clear, how I'd use your multiplication table for this. If you're like, I don't know what 6 and 24 are both divisible by, look at the table. 24 shows up there, and there. 24 is divisible by 2 and 12. It's also divisible by 3 and 8. And oh, look, it's also divisible by 4 and 6. Use the table to help you out. So what that means is that both of these are divisible by 6, because 6 is obviously divisible by itself. 6 divided by 6 is 1. 24 divided by 6, again, you can use the table. Go to 24, there's the 6, there's the 4. You're going to have a quarter there. There is no shame in using the multiplication table. You might feel it, got to get over it. If someone else makes you feel shame, I'm not going to tell you to punch them, but nobody should make you feel shame for using the tools that I provide. Axton places 15 roses in a beautiful glass vase. It holds 6 yellow roses and 9 red roses. What fraction are red? Mishwa? 9/15, which is reducible to 3/5. You bet. Comments, questions, concerns on any of those? Okay, then the next step was just, here's a bunch of fractions, reduce them. 2 and 6 are both divisible by? Well, they're both even, so divide by 2, divide by 2. You're going to get a third. 5 and 20 are both divisible by? 5, so it's going to give you a quarter. 4 and 6 are both divisible by? Guntas? 2, that's going to give you 2/3. 9 and 27 are both divisible by? 3 and 9. So you could start wherever you want. If you're starting at 9, you're going to go straight to 9 divided by 9 is 1. 27 divided by 9 is 3. If you're going to start with 3, you're going to get 9 divided by 3 is 3. 27 divided by 3 is 9. And then you have to keep going. Because 3 and 9 are also both divisible by?
3.
So 3 divided by 3 is 1. 9 divided by was 1. 9 divided by 3 is 3. You get the same result either way. I don't care what the journey is. It's the opposite of what people say. Sometimes people say, it's about the journey. Screw the journey. It's about as long as you take the journey and we all end up in Maui together, I don't care how you got to Maui. I flew direct. You through LA. We're all in Hawaii. Who cares? Okay, 8/32. Both divisible by 8. And you're going to get what, Guntas? 1/4. But you do not have to divide by 8. You could have also divided both of them by 2. You could have also divided both of them by 4. Again, show me the journey, but we should all arrive at the same destination. 16/48 is a little trickier. The numbers are getting bigger. You can use the table if you need. Guntas, how'd you do it? You went straight to the end because you're like that. If someone isn't like that, what could they have divided 16 and 48 by? Sure, you can go straight to the evens. Divide by 2, divide by 2. That's going to give you 8/24. Keep dividing by 2. It's going to give you 4/12. Keep dividing by 2, because why the heck not? It's 2/6. Divided by 2 again, divided by 2 again, and you're going to get 1/3. Or you could have done the math facts. 48 is in fact divisible by 16. Yes, Guntas. It's also by 8. It's true. 2, 4, 6. No, 2, 4, and 8. And 16. You betcha. Okay. G is... That's a math facts one. Emrys?
You divide it by 11.
Divide both by 11.
Yeah.
11/11, or 11 divided by 11 is 1. 33 divided by 11 is?
3.
That's the quirk of the 11's times tables. If you don't know them, there's no nice way to do that other than going to your table. 14 divided by 54 is? 7/27. This is a tricky one because there is no elegant... Like, I saw some people sitting there. There's more than one of you was sitting there looking for, what's the elegant one? What's the elegant one? There's got to be a big number. 2. 2 is the biggest number. That's it. 14, and unless you're willing to be like, I can't think of something immediately, they're both even, let's go, you're going to be stuck staring at it for a while. Don't think for too long. If you can't come up with something elegant, go with something simple. They're both even. Just start dividing by 2 and see what happens. You don't always have to reach for elegance. And then letter I, Guntas. Sorry, what? Start again?
You do 55, that's 140. 45, 55 is 1.
Oh, you you went mixed. I don't want it mixed. What's it improper?
20.
Okay. You would have gotten to, they're both divisible by 5, so you got to 20/11. You are more than welcome to leave it like that. Guntas wanted to be fancy And so he wrote it as a mixed number, which we're going to do, I think, in a second here. Yep. And wrote it as 1 and 9 over 11, which is not what I was expecting, which is why I wasn't sure if that's what I heard. So let us all... Okay, questions? Do we feel okay about the procedure, even if we didn't get them done? You sure? Okay. If you want to do the practice with me, let me know. Don't be too proud to get help if you need it. Let's all be fancy like Guntas. Converting between mixed fractions and improper fractions. You have a whole pizza. If I cut the pizza into 2 equal slices, you still have one whole pizza. But you could also write this as what? No. You still have the whole pizza. 2 of 2, yeah. You could say I have one whole pizza, or both slices are still there and there's 2 slices. If I cut it into 4, we could do the same thing. 1 or 4 over 4. So what we're doing is what we're recognizing, what I want you to recognize here is that you can take out wholes. If you have 4 and there were 4, that's the same as taking out a whole number of the pizza. I know it's a simple way to do it, so let's extend it. What if I have this? If I have 1 whole pizza and a half a pizza, how much do I have?
1 and 1, 2.
I have 1 and 1/2, which we generally write nice and close together, 1.5. But if I wanted to write this thing improper, what's another way I could represent this? Yeah, if I cut this guy in half, now I can see, oh look, I have 1, 2, 3 of them. Sorry, what did you say? 3 over?
1.
You sure? 2. I have 3 halves. So this is 2 over 2. This is 1 over 2. So then I have 3 of them. 3 halves. Going back and forth from here to here is what we're going to look at now, which I know a bunch of you have done already. So let's review how this goes. If you have 2 whole pizzas and a half a pizza, this you said already is 2.5. But if I cut each one of those in half, these 2 holes, if I cut them into half, how many... Well, I've got halves, so my denominator is going to be 2. How many halves do I have? Can you erase Mila's name off the board because she's back? I think that's Mila.
I did that.
Oh, that's Mesa. Never mind. Don't erase her name. She's still gone. There's 5 halves. So let's look at, forget the pizzas. Let's look at the algorithm for how this gets approached mathematically, shall we? To convert a mixed into an improper. This is the easy way. If I give you a mixed number, 2.5, and I tell you I want you to write this as an improper fraction, how do you do it? Pavni, you multiply
You multiply the whole number with the denominator.
the whole number with the denominator. It tells you what to break up the denominator or the whole number into.
And then you add.
And then you add that result to the numerator. So 2 times 2 is?
4.
And you're going to add that to the numerator. It's like you're going full circle. 2 times 2 is 4 plus 1 is?
5.
5. And the denominator stays the same.
That's actually the denominator.
No touchy the denominator, eh?
Yeah, that's what I used to.
Okay, next one. So that's the procedure. 5 times 3 is?
15.
15. Don't do more than I want you to do. 5 times 3 is 15. And I'm going to add that.
18.
So I'm going to get 18 fifths.
Yay.
I want to do another example. So those of you who have worked ahead and are like, this is trivial, come back. Another example. I want to be really clear how this gets or how negatives are involved in this process. So here's the example I want to do. Negative 2 3/5. How do I do it? Pavneet, I see that hand.
Can you do 5 times the -2?
Okay, so I didn't ask. I asked you a question. I don't want you to answer me with a question. I want you to give me an answer. So here, I want everyone to hear what's happening here because this is exactly what I hoped would happen. I said, how do you do this question? You have -2 and 3/5, and Pavneet said, do you multiply the 5 by the -2? Don't answer my question with a question. I want you to try and commit. And so what I'd like to do is I want to see what would happen if we did that. If we did that, I would say 5 times -2 is
-10.
-10, and then -10 plus 3 is
I forgot.
-7.
-7. So one possible route to get to the answer or get to a solution is -7 over 5. And the question is that correct? What's the other way to do this? Because really, let's think about this. Another way to demonstrate a fraction, which we haven't done yet, but we're gonna, is to represent the fraction as a decimal. So, what is 3/5 as a decimal? Does anybody know? No. We don't know? Okay, then let's not think about it that way. Let's think about it a different way. Let's think about it this way. I started with 2 wholes and 3/5, and that number was negative. Do I still have 2 wholes here? How many times does 5 go into 7? Once. So we lost. Okay, Geronimo and Annabelle, stop talking. Whisper at least, if you're trying to figure out what's going on here. But if you're doing something different, then shh. I know you already know the answer, but talking over you is difficult. What we're saying here, so no, if we're going to go the other way, those of you who have seen this and are comfortable with it, no, this is not going to work out because I only have, if I go 5 into 7, that's only once. So what's going on here? When you convert mixed to improper and there's a negative involved, you need to recognize that that negative is actually applied to the whole thing. What this actually needs to look like is this. Think about it as if you threw the square brackets around the thing. Convert inside there and then make the whole thing negative after. So how this thing should have played out is 5 times 2 is 10 plus 3 is 13 over 5, and then you make the whole thing negative. You got to be deliberate about how you follow the pieces. So, crank these bad boys out. I'd like you to make the bottom row all negative. G, H, and I are all negative. Crank those suckers out. If you haven't done it already, on your markets, go. What are those 9 fractions written as improper, or 9 mixed numbers written improper? Boom, boom, boom. Yes. Really you. I'm hoping this is okay.
You know what
Most of
that
you.
is? Eating my neurons and then regurgitating them into my brain.
That would be uncomfortable. This is why he shouldn't go to the bathroom while I'm in the middle of a lesson, unless it's an emergency. Which part did he miss? All of it. Oh, well, there it is.
Yeah.
Unless it's a dire emergency, don't go while I'm teaching.
I have English after this.
Okay. Done.
They're getting too small. If I get the size 10, then I'm gonna be big, but.
You ignore the negative
But you said.
and add a negative back in that.
I got the big toe, you're not gonna have it.
Yes. Yeah.
Oh.
So yes, 10 times 3 is 30 plus 1 is 31. Bring the negative back. 13 is 26 plus 2 is 28. Negative, yes. 7 times 5 is 35 plus 3 is 38. Negative, yes. Crank them out. Those of you who did finish already, go back.
No, my dad was.
Okay, I want you to make.
I'm taller than my mom. So the same 5 foot, I'm 5 foot 8. So I'm not percent, I'm comparing. Don't tell me my 3. What? Because sometimes I get lost. Probably should you like sandwich, I feel like a sandwich with cheese and salted butter.
There's 3 plus 2. You have a whole number here. This fraction is less than 1. You should never smaller than
So if you have 1/3 of something,
I think as long as you're not like with it, you should go on it. Let me see your
so if I have 1 and 2/3 of a pizza, that means I have a whole pizza. And
It's
is this much of the pizza. What you're telling me is this whole pizza and 2/3 of the pizza is the same thing as
Are you now like self-conscious about it?
this is, if I said I'm having you over for pizza, is this the same amount?
Oh, you hold on, yeah, I think it's 20
here, and then I think we're.
The denominator stays the way it is just because that's the denominator. No, you do it, so you do 11 times 2 is 22, plus 1 is 23. Yeah. So this times this, and then that number plus this zero. Yes. And the denominator stays the way it was, yes. Yes, yes, yes. I'm not going Friday nights. But I got a 2-year-old and a 4-year-old at home. My wife's going up. So I'm gonna go home and be a dad. Okay, so let's see what we got. Okay, so let's crank these things out. You should have gotten 5/3, 9/2, 23/6, 23/11, 16/3, 7/3, -31/10, -28/13, -38/7. The denominator always stays the same. You multiply the denominator by the whole and you add that result to the numerator. If it's negative, you ignore the negative, follow the procedure, and then add in the negative after. Say, hey, put your phone away. If I have to ask you again, I'm going to send it down to the office. Okay. Last bit. We're going to finish this up. Here we go. I know there's only 7 minutes left. Here we go. Let's go the other way. We want to convert improper fractions to mixed fractions. Again, review. Stuff you've done before. To go the other way, we want to multiply the denominator by the whole number until you get, by a whole number, until you get as close to the numerator as you can without going over. So the written instructions are a little weird, so bear with me. The number you multiplied to the denominator becomes the whole number. Subtract the numerator using the answer from the multiplication. Again, this sounds confusing, so let's just do it. Here's what I would say. This is the fraction. The improper fraction we've got is 11 over 2. How many times does 2 go into 11? Or what number would I multiply 2 by to get just under 11? 5. And so what we're going to say is that number, 5, is going to become the whole number that goes out front. 2 goes into 11 5 whole times. Because 2 times 5 is 10. So because 2 times 5 is 10, I'm going to take 11 and subtract that 10 from it. 11 minus 10 is 1. And the denominator is what the denominator was. So if I have 11 halves is what this means, that's the same as 5 wholes and 1 more half is what is the equivalence there. I'll do 2 more examples, then I'll leave you to it. 15 thirds. What whole number would I multiply 3 by to get up to or 15? 5. So I have 5 wholes here. Do I have anything left over?
No.
Because 3 times 5 is 15. 15 minus 15 is 0. So there is no mixed fraction. Sorry, there is no fractional part of this mixed number. It's just a whole number. It's a silly question. You could theoretically, someone tried this the other day. 5 and 0 thirds. While that's true, we'd never write it. We just leave it as 5.
Or you could do 5 over 1.
No.
No?
Bad. That's not bad, but we don't write that. Okay, last one. 14 fifths. What does 5 multiply by to get just under 14? Leela?
2.
2.
Yeah.
Mila?
Mila. I thought I heard Leela.
No.
Yeah, I did too.
Leela's the one-eyed person from Futurama. That's not you. She has purple hair and is a cyclops. Very different. So, because 5 times 2 is 10.
Yes.
So 14 minus 10 is
4.
4. And the denominator stays the same.
Yay.
So 14 fifths is going to be 2 wholes and
4 fifths.
4 fifths. Okay, in the time that remains, I'd like you to write down what I want you to practice for homework. Here we go. I want you to do these 6. This is homework. Then I want you to flip the page. There are 9 questions up top, and I would be a monster to get you to do all of them, so I want you to do ACEs. ACEs is every other letter starting with A. So A, C, E, G, and I. Half of the questions. Then down here on number 2, I don't want you to do ACEs, I want you to do BDUFs. Every other letter starting with B.
Are these actual?
B, D, F, and H.
Are these actual words?
Then I want you to flip the page. You shouldn't need to ask that. Then I want you to flip the page again. I want you to do number 3. I want you to do ACEs again. A, C, E, G, I, and there shouldn't be 2 H's. That should be a K.
I just realized what? Are we going to do
That is all.
I know.
That is your homework for the weekend. Have a super duper day. There's 2 minutes left. You can start working on this and wait till the bell, like a enterprising student. Or if you're just over it, you can call it, pack your stuff up, and spend some time this weekend practicing the math. If speed is your problem, the only thing gonna make you better is practice. Good luck. May the force be with you.